Let's explore the idea. Explore each set of conditions described below on a separate sheet of paper. Draw several triangles to match the description. Then make a conjecture about the number of different triangles possible and justify your thinking. Problem 2. 3 sides are given. Use side lengths 6 centimeters, 6 centimeters, and 4 centimeters. How many different triangles can you make? Problem 3. 3 angles are given. Start with angle measures 80 degrees, 40 degrees, and 60 degrees. Try other sets of angles such as 20 degrees, 120 degrees, and 40 degrees. Try 3 measures that don't add up to 180 degrees. Problem 4. 2 sides and the angle between them are given. Start with side lengths 5 centimeters and 4 centimeters, meeting to form a 45-degree angle. Then try side lengths of 2 centimeters and 4 centimeters, meeting to form a 90-degree angle. Problem 5. 2 angles and the side between them are given. Draw triangles with a side 4 centimeters long and a 45-degree angle at each endpoint. Try different angle measures and different lengths for the side between them. There is also problem 6, but we'll come back to that after. So what we're going to do is I want you to pause the video and try these problems, these 4 problems, and then when you're done, unpause and we will reveal the answers for all of them and go through it. Problem 2. Again, 3 sides are given. Use side length 6 centimeters, 6 centimeters, and 4 centimeters. How many different triangles can you make? For any 3 side lengths, if you can make a triangle, there's 1 possible triangle. Look at this triangle, for example. Let's say this is 6 centimeters, 6 centimeters, and 4 centimeters. It's not drawn to scale, but let's say if I rotate it, it still stays the same length. There's only 1 possible. If I move it, right, there's only 1 triangle. Let's look at problem 3. 3 angles are given. Start with angle measures 80 degrees, 40 degrees, and 60 degrees. And then try other sets of angles such as 20 degrees, 120 degrees, and 40 degrees. Try 3 measures that don't add up to 180 degrees. Let's see what we got for this one. If 3 triangles add up to 180 degrees, you can make any size triangle and they will have the same shape. Think about that. Okay, let me draw, let's say, an 80 degree by 40 degree by 60. Alright, let's see if we have, just making this up again, 80 degrees. I can make it as long as I want if you think about that. 40 degrees and 60 degrees. Okay, so let's say this is my 80, 40, and 60. Okay, I can shorten those line segments. Watch. This line segment can be shortened. There's my 80. Okay, there's my 40 and there's my 60. Okay, so you can make any size triangle as far as lengths. Problem 4. 2 sides and the angle between them are given. Start with side lengths 5 centimeters and 4 centimeters, meeting to form a 45-degree angle. Then try side lengths 2 centimeters and 4 centimeters, meeting to form a 90-degree angle. Okay, so let's actually do that before I reveal the answer. So let's look at this. Let's say I did a 5 centimeter line segment and a 4 centimeter line segment. Okay, 5 centimeters and 4 centimeters. Okay, and they form 45 degrees. Okay, so let me do 45 degrees. Okay, Think about that. Then try 2 centimeters. Let me do a different color here. 2 centimeters and 4 centimeters. Okay. So 2 centimeters. Let me write the units so we're all on the same page. 2 centimeters and 4 centimeters. And they form 90-degree angles. Think about that. Okay. Given 2 sides and the angle between them, you can draw one unique triangle. Let's look up here. We're going to use different colors. The reason why you can only draw one unique is because these lengths, okay, they are what they are, 5 and 4. And then you have the measurement here at 45 degrees. That's not going to change. So there's only one unique triangle you can make that connects here. That's it. Doesn't matter how many times I flip it or slide it, etc. Same thing here. Okay, we know this is 90 degrees. 2 centimeters will never change. 4 centimeters will never change. The 90 degrees will never change. So there's only one line segment that can close for this triangle. That's why you can only draw one unique triangle. So that's a rule for later on in this lesson. Problem 5. 2 angles and the sides between them are given. So now 2 angles and the side between. Draw triangles with a side 4 centimeters long and a 45-degree angle at each end point. Try different angle measures and different lengths for the side between them. And as you can see for problem 5, given 2 angles and the side between them, you can draw one unique triangle. So let's look at that as well. So if I have, let's say, 4 centimeters, okay, 4 centimeters, and 45 degrees here. Remember, it's got to be acute. So this angle needs to be something like this. Okay, and then another 45 degree here. And another acute. Okay, so if those are 45 and 45, there's only one unique triangle. Okay, so let's review this. If you have the lengths of 2 sides and an angle measurement, then you can only create one unique triangle. If you have 2 angle measurements and 1 length of side, then you can only make one unique triangle. Let's look at this problem. How many triangles can you draw with side lengths 2 centimeter, 3 centimeter, and 5 centimeter? Try sides 2 centimeter, 3 centimeters, and 8 centimeters. Explain what you find. So pause this video, solve it, and see what you've come up with, and then you can check your answers after you unpause. And the answer is no triangle has either set of sides. The short sides are too short because they add up to the long side and lie flat. The 2 shorter sides have to add up to more than the third side. That's called the triangle inequality theorem. Triangle inequality theorem tells us the 2 shortest sides must add up and be greater than the third side. Okay, you can see here the 2 shortest sides here, 2 and 3. 2 plus 3 must be greater than the third side, and 2 plus 3 is not greater than the third side. Look at this one. 2 and 3 are the shortest sides. 2 plus 3 is not greater than the third side, and therefore you cannot create a triangle.